I'm now delighted to be joined by Ian Funnell, who's CEO of Hitachi and Energy for UK and Ireland. So, a massive welcome to you, Ian, first of all.
Thank you so much, Adam. Great to be here.
It's great to have you as well. So, I'd like to sort of obviously go through a few questions with you because you have obviously a very senior role at Hitachi. Hitachi are a very progressive and innovative company when it comes to smart grids. So, um, we heard earlier a lot about the opportunities and, let's say, challenges facing network operators at the moment and going forward. So, what opportunities do network operators face, especially in the era, as we all say, about energy transition? And also, what challenges do they represent?
It's a brilliant question and really topical, of course. And you have to think about energy systems. When they started, you go back to the energy revolution of the first industrial revolution, I guess. That's 250 years ago, really, and where electricity started, and that's about 140 years ago. And the whole system has grown incrementally from that point, and to the system that we know and love today. And one of the challenges, I think, is to say, look, is the system as it stands at the moment fit for purpose in an era where the criteria is fundamentally different to the one that when the energy system was originally built and designed. And I think there's a real challenge there for us all to say, look, we need to take a whole systems approach to think about how the energy system and the multi-vector energy system can be developed. And I think so there's a fantastic opportunity there, I think, to look at it in a completely different way, to understand what the supply and demand equations are going to look like, in future, because they will differ. And I think we have to understand also where the energy vectors are going to be. What are the energy vectors? Are they going to be electricity? Are they going to be ammonia? Are they going to be hydrogen? What are they going to be? And where are they going to be sited? And so there's a balance there, I think, between what the national infrastructure network needs to look like to enable the whole energy transition, and what local area energy networks perhaps need to look like as well.
It's a very good answer because I think we covered that a little bit, especially with Lucy as well this morning. There's an opportunity and a threat, I think, from both sides. But I think decarbonizing networks is probably going to be a really, really big challenge. I sort of do agree with you that we have to move very quickly, but in a very smart way as well. How can I ask you, how would you decarbonize electricity networks? Because we're sure we're going to hear many different views from many different people today about how to do it. But from your perspective and your role and the role you do within Hitachi, what would you do?
So I mean, decarbonizing networks is a bit of a challenge. I mean, it's easy to decarbonize the supply side because you just build more windmills in the North Sea.
Yeah.
But in terms of the network themselves, you got to think about how companies themselves can decarbonize. So for example, Hitachi Energy as a supplier to the network operators, our plan is in place to decarbonize at least scope one and scope two emissions by 2030. And some of that is relatively straightforward. Some of it is about the energy that we consume. So we've just signed deals globally, which takes carbon out of our entire electricity supply globally. Now that's a relatively easy move to make. By the time you get to some of the other scope one and scope two emissions, it's not quite so easy. So particularly things like travel, and also
Mm.
things like scope three emissions, which we have a plan for 2050. That's the really difficult part. So our scope uh, one and two almost is the electricity company's scope three, and so we have to get our act together in order that the network operators themselves can become carbon neutral. But it's about, I think there's probably two things in there. One is it's about leadership for sure. It's about
Mm.
organizational leadership. It's about leadership from governments, but it's about personal leadership as well. And I challenge regularly. everybody to say, so what is your personal carbon footprint, right? Do you even know what it is, right? I mean,
It's a good
mine,
question.
I've calculated mine. It's just over 10 tons. There's stuff I can do. There's stuff I am doing to reduce that. But if you don't know where you're starting from, you actually don't know necessarily where you need to go and the steps you need to take. So there's certainly a challenge there.
That's a very good. I've never heard that question actually. I have no idea what mine is. I don't know, and I think a lot of people won't know what theirs is. So that's. I'd like to hear it. Yeah, I'll message you on that a little bit later because that's a very interesting point actually. Um, you mentioned obviously leadership from yourself and others, but also we're going to probably hear more and more a bit later today on policy and regulation. I think that plays a big role in how this all plays out. How important is government regulation, especially in relation to supporting all of the net zero initiatives?
I mean, it's I think if you want to attract investment into this whole sector, and the sector really is a sort of net zero sector, which covers every aspect of our lives. Then I mean, government and regulatory policies and support and procedures are really critical. Without that, it just doesn't happen. And you look at some really good successes. So you look at the supply side of electricity, offshore wind. You look at the CFDs, ScotWind. People are lining up to invest. Uh, why? Because the government have a really robust policy, and you could say it's world class. So if I was the schoolmaster, scoring government on their policies for the supply side, I'd be scoring them 10 out of 10. I think it is either world class or very close to world class. If I was scoring government out of 10 for decarbonizing the demand side, then
Mm.
then I would be saying they have to do a lot better. And if I scored them one, I think I would be being very generous. Um,
Oh wow.
so I think there's an awful lot to do on the demand side. We're nowhere near where we need to be on the demand side. And from a regulatory point of view, there's a piece there about the whole philosophy of regulation is about investments of no regrets. The real
Mm.
world always has regrets, and I think it should either be low or managed regrets, because we're trying to turn this super tanker around. From having started this journey 240 years ago, we're trying to turn it around in 8 years.
Mm.
There's no rule book. We've never done it before. We're bound to make mistakes along the way. So with a theoretical philosophy of a no regrets, investment policy, that isn't going to happen.
Mm. Yeah, I mean, it's just a lot to do in a very short space of time, and I think that's where we go, especially with an event like this. You talk about how technology can be a bit of an enabler for accelerating energy transition. Because I mentioned to Lucy earlier in my opening remarks that people were talking more about decarbonisation and technology as two completely separate issues. Um, let's say 3 or 4 years ago. Now they're quite, they're talked about in sync. So how do you think, how significant will technology be, especially in the role of decarbonising the networks, the economy, the customer, all of us? What does the future hold? Because it's quite scary when you read the news about how quickly we all need to move out of what we have been doing. But what are your final thoughts on that, Ian?
Yeah, I mean, yeah, we all need technology to be able to do this. I mean, we're transforming, the energy networks from something that was largely passive to something that is going to be extremely active. It's going to be active on the supply side because supplies are variable. I mean, there will be wind, there will be solar, there will be energy storage, be nuclear, for sure. But it is a much more active network. And therefore, technology
Mm,
plays an integral part in that, because you cannot control a complex multi-vector energy network manually. So the
mm,
degrees of automation, the degrees of anticipation from artificial intelligence can be absolutely key. The technology, however, exists today that probably gets us at least 70% towards net zero. You know, we're not waiting for 20 years for R&D. There's still R&D to come, of course there is, but you know, but the technology exists to get us a long way down the journey. And you know, as you mentioned earlier in your opening remarks, you know, pace is extremely important. We need to start this, and we need to start it now, because a ton of carbon saved today, accumulates to whatever 27, 28 tons by 2050. You know, a ton of carbon saved in 2049 is just 1 ton. You know, and so you know, the more we can do early, the better. So I think digital tech, very important. It's going to be, you know, the balance between supply and demand. We are going to increasingly have active consumers who will be managing their whole energy consumption from their iPhones. Some say prosumers, but to be honest, I hate the term. But nevertheless, it's that sort of thing. You know, but they're going to be managing when at least when they plug in their cars. The network itself, however, needs to understand when it needs to supply and when it needs to take
Yeah.
off from electric vehicles. So tech is important.
Yeah, that's a good point, because I think that's going to be a big issue about when you need the energy. There's going to be a huge demand for charging your electric cars at certain points of the day. Will that be managed correctly? So, Ian, it's been fantastic speaking with you. It's a real honor to have you actually as part of this event. I know you're going to be moderating the next panel as well, which I'm very excited about. So, but thank you very much for joining me, Ian, and hopefully we'll speak again later on today.